Hello, my name is Jim Cordell, and I am a full-time faculty member for physics here at Westmoreland Community College. So I'm going to give you a little description of our Physics Associate of Science degree. Okay, it's relatively new. Just a couple years ago we got it started, and we haven't had much enrollment in it yet, but hopefully that'll change. So I just want to show you what you would expect from the Physics AS degree. Okay, so let me share my screen with you and show you the catalog page for it first. So when you're taking an AS degree here at Westmoreland, you're going to take a personal PDV course that is just for these STEM majors called PDV 171. So it's not the regular one, but it's one for STEM majors. And you'll also, at the end, in the last semester, you'll take a PDV course that is for STEM majors called STM 296. Okay, let's take a look at what are some of these courses. You're going to end up taking Engineering Physics 1. It's a calculus-based physics course. Engineering Physics 2, that's another calculus-based physics course. Thermodynamics and Fluid Mechanics, that's another relatively high-level physics course. And also Modern Physics, that's where you talk about things like relativity and quantum mechanics. So those are the 4 physics courses, and they're relatively high-level physics courses for community college. You need to have already had high school physics first before you can start taking Engineering Physics 1. If you jump right in, not having any physics background, you'll be way over your head. So you have to have had high school physics first. If not, you can take another course at Westmoreland called Physics 110, Fundamentals of Physics, that gets you ready for it. But you also should be at least taking Calculus 1. So you see that first semester, Calc 1? You need to be also taking Calc 1 because this is a calculus-based physics course. So we need you to get some calculus skills along the way. So you should at least be taking Calc 1 at the same time. And you'll also notice that this degree has a lot of math in it, which really any physics program should have a lot of math in it. Math and physics are buddies. Okay, they work together. So if you think you want to get a physics degree, you really want to bone up on the math and think, am I good at math? Because a lot of math is involved. Okay, so another thing we want to look at is these 4 courses I pointed out. So let me share those screens with you. Okay, the first one is Engineering Physics 1. And I just want to show you what that involves. So here's an outline. Kinematics, that's the study of motion. Then dynamics, that's when we start to include forces and how it affects motion and the idea of work and energy and momentum. Then we look at rotational motion, laws of gravity, and how that affects satellite motion. Waves are very important in describing the world around us. And thermal physics, little heat transfer and thermal properties. We talk more about that in a later course. Now, again, all this is calculus-based. And then let's take a look at the next course. That is 256. Now we get into electricity and magnetism. Okay, alternating current, of course, is more electricity. And then light, optics and light, the nature of light, interference, diffraction. Okay, and then also we get into some modern physics. Talk about fission and fusion and some quantum mechanics. And that's the bottom part here. You have waves behaving as particles and particles behaving as waves. That's part of quantum mechanics. So we're starting in on modern physics. And again, we'll see that later in another course. And so if we go on to 259, let me find that one. There we go. Okay, here is thermodynamics and fluid mechanics. Thermodynamics has to do with heat transfer and the nature of matter, talking about what temperature really is, thermal properties of material, changes of phase, work, thermodynamics, we talk first law of thermodynamics, and then second law of thermodynamics. Now those terms are words that you're going to hear in engineering, and that's probably one of the main things I want to mention about this program is that this is the best program at Westmoreland right now if you are interested in engineering, because if you want to be an engineer, these are really a lot of the courses that you will be required to take your first 2 years in an engineering program. So really, this is one of the best fits for it. We're hoping to develop a full-fledged engineering AS degree, but right now, engineering technology that we offer is not really going to prepare you to become an engineer. You'll see that the courses don't really match up real well for a regular engineering program. But these are really, a lot of these are things that you're going to see more of in engineering classes like thermodynamics. You have a whole course or two, usually a couple courses on thermodynamics, right? And same thing with fluid mechanics. You're going to see, like whole courses on fluid mechanics. But here's our introduction to it. Okay, and then one more course I want to show you, and that is the modern physics. So what is modern physics? Well, we start talking about relativity, Einstein's theory of relativity, and then into quantum physics, light behaving as particles, particles behaving as waves. That's the similar thing we just mentioned in engineering physics 2. And then more about waves, more detail, and then getting into the atomic structure, and then molecules and solids, and band theory. And this all has to do with quantum mechanics. And then finally, nuclear physics, nuclear structure, radioactivity, fission and fusion. This all, again, has to do with, you end up looking at E equals mc squared. Okay? So this is just an idea of what you'd be looking at in those relatively high-level physics courses. I say high-level for community college, they certainly are. Okay? And again, one of the main things I want you to take away from this is that why would you take this degree? One reason would be, let me stop the share here. One reason would be that you want to be a physics major at a 4-year school. Certainly that makes sense, right? This would be a great start. And another would be if you wanted to be going into engineering, because like I said, a lot of these courses are the courses that they're going to require your first couple years at engineering program. So this would be a great way to get started there. And with the AS, then you go on to the 4-year degree. You already have a degree in hand before you even go off to your 4-year school. So those are some good reasons to do it. And by the way, while you're here at Westmoreland, you could also take some courses in solid modeling. I teach physics here, but also Dr. Frank Stasa does also. We both have degrees in engineering. Okay, Dr. Stasa has a PhD. That's why we call him doctor. And actually it is good by Frank. But anyway, solid modeling is something that is used in a lot of engineering jobs. A lot of times when you look at an advertisement for a job, if there's a job opening, a lot of times they'll ask you to have experience in something like SolidWorks or Inventor. And those are some courses that you can take while you're here. Now, they're not part of the physics program, but hey, while you're here, might as well take those. You got those under your belt too. You could maybe get a job because you know Inventor and or SolidWorks. Okay, so that's my spiel about the physics AS degree. Hope it sounds appealing to you. Hope you're willing to challenge yourself because it is relatively challenging, and hope to see you soon. Thanks.